Hello, everyone, and welcome to our October member meeting, where we are honored to have Ed Mazria, FAIA, and our discussion on climate change and what architects can and must do. This meeting is presented by LGA Architecture. And I want to also thank our visionary sponsors, John A. Martin and Associates, Clyde Jubal-Wald, and Knit Studios. Our platinum sponsors, Nevada Sales Agency, TJK Consulting Engineers, Harris Consulting Engineers, Nevada Lighting, and 501 Studios. Our gold sponsors are American Insurance and Investment, Assurance Limited, AIA Landscape Architecture, Southwick Landscape Architecture, Loxa Engineering, and Terp Consulting. Our silver sponsors, Bank of Nevada, Core Construction, Helix Electric, JLLP Inc., Nevada 5, Lage Design, Hogemeyer Design Group, SR Construction, EPG, Silverlands Inc., and LGA Architecture. And now it is my pleasure to turn the program over to Lance Kirk, our president, and he will lead us into this evening's discussion.
Thank you, Randy. Good evening, everyone. It's wonderful. Thank you for taking the evening with us this evening. Before I introduce our speaker, I want to take a few moments to recap the last 10 months where our focus has been on climate change, taking action to transform the practice.
Fossil fuels by 2040. We'll talk about that. Is it doable? We want to know, how do you do it? All that. We'll go into all of that. But the reason that 1.5 is critical is you think we're in a drought now. If we don't meet the 1.5 and we sail past that 2 degrees C, climate change essentially becomes irreversible and the impacts keep getting worse because there's so much inertia with CO2 in the atmosphere that the planet keeps on warming. If we stay at the 1.5 or a little bit slightly over, but in that range, then we can bring the planet, once we phase out emissions with drawdown, just even natural drawdown, the planet then begins to come back to pre-industrial levels, essentially heal itself in that sense. Okay. The projections are between now and 2060, every week, about 1.5 million people are being added to cities worldwide. This is a population graph of Nevada, and you can see you guys have been on an exponential growth curve, just phenomenal. There's a little bit of a slowdown you can see here in 2010. Of growth because of the economics and the recession. But after that passed, 2007 it started, 8, 9, 10, and then all of a sudden population growth takes off again. So you're right on that, exponential population growth curve. Now, we've heard a lot about density and COVID, and it's a risk factor for spreading the pandemic and people thinking about leaving cities. So let's talk about density just quickly. There was an analysis done, it's just recent, and it was just put out, of 913 counties in the US. And it indicates that density is not a COVID infection risk factor. What is overcrowding. Is when you put a lot of people into an event, or even in a building where you we've seen in low-income communities, you know, two families occupying the space that one family should occupy. When you get overcrowding, that's the risk factor. Density is not the risk factor. In fact, suburban and rural areas, according to the study of counties across the U.S., show that the death rate because of COVID is much, much higher in suburban and rural areas because they don't have access to medical facilities. And we're even seeing that play out right now as we speak. So how do we get to what we call a carbon positive built environment where we start to get some of that drawdown? Well, we say it's a two-step process. Step one is planning, design, and construction. That's what we do. And electrification, electrifying buildings and building operations. Step two is renewables, is adding the renewables. So step one is huge. The design process and what we specify will get us 70 to 80% toward carbon positive. The other 20% then is the renewables. And what do we mean by step one? Well, that's everything from urban growth boundaries, infill, walkable communities, bringing agriculture into urban areas or urban agriculture. That gets us drawdown, actually. We begin to grow our own foods, to passive heating and cooling systems, dealing with the heat island effect, natural ventilation, how we build our buildings, what materials we use, and if we begin to use materials that actually draw down carbon positive materials. That gets us 70 to 80% of the way to carbon positive. And then the other 20 to 30% is obviously on-site and off-site renewable energy production, because buildings will always use energy. So this is 2005 to 2019. I'm going to show you GDP. This is gross domestic product. You can see the recession that we went into at that period, and that's when we saw slow growth in Las Vegas, and then it picked up again as GDP picked up. We know that building floor area picks up, and we've seen that too. We've added, since 2005, 47 billion square feet to our building stock in the US. But something incredible happened. Usually when floor area goes up, energy consumption goes up. In the US, energy consumption of the entire building sector, even though we've added 47 billion square feet, is actually down 1.7%. And if we look at greenhouse gas emissions are down 21%. When you think about it, if we're not using any more energy in our buildings, even as we build, because we're building more efficient and renovating, then every time we add a collector, it replaces fossil fuel energy. Or anytime we build a wind farm, or anytime we do any of that, it replaces fossil fuel. So emissions are going down even faster. This decoupling this is unprecedented. We've never seen a decoupling of GDP and emissions. And you heard back when we talked about, well, we need to reduce emissions. We talked about all the hundreds of billions and trillions of dollars it's going to cost. Hadn't cost a penny yet. And in fact, we've saved hundreds of billions of dollars in energy costs by doing this. And we're starting to see that decoupling now globally. This is world GDP and floor area. You see they go up together. You build more, obviously, as you have a better economy. But you can see energy use and emissions now decoupling worldwide. That is enormous. It's not going down yet. We need to drive it down, and we'll talk about that. So can we reset now to meet the 1.5 degrees C budget, which now is not the 2050 date, but is the 2030, 2040 phase out date? Let's talk about that. The built environment, energy consumption and emissions comes from three areas. One is new buildings, building operations. As we keep adding buildings, we obviously are adding energy consumption, and if we use fossil fuels, emissions are going up. existing buildings that are operating now. We have millions of buildings. New York City itself has a million buildings. So we have millions of buildings that we have to deal with. They're all using energy and emitting carbon. And then the third thing is materials. If we're going to build all this building, as the economy grows and we put money into infrastructure after the pandemic, that's where most of the local jobs are going to be. Embodied carbon becomes a huge issue. Energy consumption and embodied carbon. So let's deal with these three items. First, building operations from new buildings. We need to bring all new buildings in at zero carbon. This is a no-brainer. We have the code structure to do it. We have zero codes. You can go to zero-carbon.org and see it, and you can get them. It's now in the 2021 IECC coming out this month. And any code then can become a zero code because we're not using any special code. We're just adding to the codes that exist. So this is how it happens. You may have heard a presentation by Vince and some of our folks on this, but I'll just review it very, very quickly. You design an efficient building. You use just the standard code. Whatever code you're using, it's probably efficient enough. So you design an efficient building using try to use the most current code standards because they're the most efficient. And then you address the remaining energy that a building's going to need because it's going to need energy either with on-site or on-site and off-site renewable energy. To meet the zero code, you have obviously two pathways. One is the prescriptive path because you're using a national code standard, and there you're just checking off the boxes. And the national code standards have been evaluated for cost effectiveness. They go through a very, very, very rigorous process. So nothing in there is not cost effective. And they come with all sorts of bells and whistles. So ComCheck, you can check off the boxes, and ComCheck will certify that your building meets that. There are also in ComCheck's become very sophisticated now. There are also trade-off options. If you want to do less in one area and more in another area, you can plug those trade-offs in to see if you meet the code. So it has all sorts of trade-off options. It does the analysis behind the scenes. Once you meet the prescriptive path, you get a compliance certificate. You take that to the building department, and you're off and running. Real simple. If you don't want to use the prescriptive path and want to do your own thing, all the models, all the modeling, DOE2, Energy Plus, IES, all the computer models will generate a base building based on the prescriptive path, give you an energy use intensity, and you can model away, and as long as you get under that, you'll meet the prescriptive, you'll meet the requirements of the code. So you could use either path. Once you do that, you can go to the zero code calculator on our website, and it'll estimate the energy consumption that your building is projected to use. Once you have that, you know how much on-site and or off-site your renewable energy is required. What that does is it creates a predictable and reliable market for renewable energy. So that's one of the great things about the codes. But let me show you what the code does. This is CBEX 2003. We established that as a benchmark with AIA and ASHRAE and everyone. We all agreed that that's going to be the benchmark. Let's see how far below that. That was roughly a building built, or in the year 2000, roughly 2000, 2001, 2, 3. So this is for 4 cities. You see Las Vegas all the way to the right. This is an office building, 100,000 square foot office building. That's the average back then. So how far have we come? This is if you use ASHRAE 90.1 2019 or the 2021 IECC, the latest national code standard. That's how much energy your building is going to need. Look at we've squeezed everything out that we can. And in fact, the 2016 is also very efficient. The 2019 got about 6 or 7% of the way below the 2016 ASHRAE. So either one of those is fine. But also look at this. That's what's not regulated, is the plug load. So you see what's left is what's regulated by code in the lighter blue area. There's not much more we're going to squeeze out. Every 3 years we can squeeze another few percent, but that bar is going to move down slightly every 3 years. So our codes are terrific. We can see the same thing in this is a K through 12 school. We can see what the reduction is and what the code targets, and the same thing in an apartment building. We're way down now. Our codes are really terrific. Okay, so how's Nevada doing? Let's look at Nevada. Let's look at building energy consumption between 1960 and 2018, which is the latest data we have. So residential first. You can see it was growing. Nevada was, Las Vegas was growing. We had the recession around 2007. You can see energy consumption flattened out. There wasn't much growth then. And then as soon as it started growing again, boom, energy consumption goes up. So we have essentially big growth pattern in residential. What about commercial? Same thing. Flattens out a little bit around 2009, 2010, 11, and then boom, takes off again. So energy consumption is not following the national curve. In Nevada, it's going up. Well, what about greenhouse gas emissions? This is 1990 to 2017. Let's take a look at emissions, greenhouse gas emissions. Greenhouse gas emissions in the state went up around 2010, 7 to 10 during the recession, went down, and then headed back up again right after that. So you're on a growth trajectory. You're not doing as well as the national numbers are coming in at. So if you adopt a zero code, and it's now an appendix in the IECC, if you adopt a zero code, then all new buildings are zero carbon. That increase stops on a dime. And then as you renovate and as you add renewables to the grid, then emissions start to come down. So the zero code is critical in doing that. China just developed their own nearly net zero energy building code with on-site and off-site renewables, getting them to zero carbon. The cities now have to begin to adopt that. And in Europe, the beginning of next year, every country is expected to have a nearly zero energy building code with on-site and off-site renewables in place, required. So we know how to get new buildings to zero carbon and stop the rise dead in the building sector. It really is a no-brainer. But what about existing buildings? What about the billions of buildings that exist today that are belching out carbon and using an enormous amount of energy? Well, how do we get a handle on that? Well, we need policies. Look at Seattle now. This is an aerial view of Seattle. That cluster of buildings right there are over 20,000 square feet. Those few buildings, now that Seattle runs out for miles and miles, those few buildings, 5,000 of the 181,000 buildings in Seattle, those 5,000 buildings are only 2.8% of the total number of buildings in Seattle. That 2.8% of buildings, those very, very large buildings, are responsible for almost half of all Seattle's greenhouse gas emissions. And then the 180,000, 90,000 other buildings, so that's 5,000 buildings, are responsible for the other roughly half, 55%. What about New York? Does that same analysis transfer? Well, that's less than 2% of the buildings are located in Midtown, Lower Manhattan, downtown Brooklyn. They're over 50,000 square feet. There's 26,000 buildings out of 1 million. Less than 2% are over 50,000 square feet. So a very small number of buildings. Those 26,000 buildings are responsible for 48% of all New York City's emissions. And you can see the miles and miles of one-story buildings. This is a three-dimensional model, so it's kind of teeny, but that's the boundaries of New York, roughly. It goes a little further out to the right in Queens. What about Minneapolis? Well, you see the same thing. 1.1% of the buildings, a little over 1,000 buildings, 1,400 buildings, 1,500, are responsible for 47% of all Minneapolis's emissions. You see the same thing in city after city. This is Long Beach, along the river, all the along the waterfront, or all the large buildings, and then miles and miles of small buildings. Those buildings are responsible for almost half of all emissions. Same thing in Philadelphia, same thing in Phoenix, same thing in Los Angeles. Actually, the same thing in Las Vegas. You see the large buildings around the Strip in downtown Las Vegas, and then miles and miles of one-story buildings. And here you see a pullout, and you see that's where all the large buildings are. You can see the large footprint, and then miles and miles outside of that of small buildings. So, knowing all this, we can create some incredible government policies, and that is establish an emissions threshold of big buildings. You start with the biggest buildings, the biggest energy consumers and emitters, and work your way down the big buildings until you get to 50% of emissions. You'll only have a handful of buildings, and you establish that threshold. It's 20,000, 30,000, 50,000 square feet. It'll be somewhere in there, and that'll give you 50% of all building sector emissions within your city. So very few buildings. And then you have the miles and miles of other buildings, and that'll give you the other 50%. So now we can develop a two buildings policy. We can establish a big buildings policy for a small number of buildings. For those buildings, the big building emitters, we say by 2030, you get to zero carbon. You give them 10 years to do it. Within that, you're usually going to have a capital improvement cycle, and to just upgrade to electrification and some efficiency measures, you can get to zero carbon. Very, very, almost at 75% the cost if you force somebody to actually do it. So you give them a good time frame to do it, and they electrify and then add the renewables, either on-site or on-site and off-site. And you give them incentives so they don't all stack up, these buildings and stack up at 2030, because there's usually a penalty after that if you don't meet the zero carbon standard. You can fast track permitting, low interest loans, tax abatements. There's all sorts of things. Equipment discounts to go to electrification and rebates. You get them, it's not rocket science, you can get them easily to zero carbon. As long as you give them enough time, and 10 years is plenty of time. You'll usually hit a capital improvement cycle. For all other buildings now, these are now hundreds of thousands of buildings. There you look for building intervention points. When the building is actually going to get renovated or upgraded, that's when you require, because it costs very, very little to upgrade and electrify. So you look at building intervention points, everything from if you're going for a zoning or use change and you're going to redo the building and add another story, turn it from residential to commercial, whatever. You're giving them something, you want them to get the zero carbon. Point of sale. The new owner coming in, buys a building, they have the financing in place. It's very inexpensive to upgrade and rate it into the mortgage. And you give them so they don't all stack up. You need to get to zero by 2040 for all of those buildings. So if you do them incrementally every year, you have a consistent way to do that. And you give them incentives so you get people to go early. Same kind of thing. If you do that, you get the entire building sector, existing building sector, to zero carbon. Now, you also get a benefit from that. All the embodied carbon, when you rip a building down and build again, you have to pour all that concrete, new steel, everything else. The embodied carbon is huge. if you renovate buildings, you save all that. You're not likely to demolish those buildings. That saves a huge amount of embodied carbon. So you get an additional plus. Okay, so now what about embodied carbon? What is that all about? Well, it's been a tough one for years and years trying to figure this thing out. I think we have it figured out. But there are literally millions of materials that we can choose from when building a building. Everything from paint to carpet to steel, brick, concrete, glass, you name it, sealants. How do we get a handle on it? And a whole industry has kind of grown up with their own language. We don't even understand what's a PO, what's an EPD or an LCA, what's a PCR, product category rule. I mean, most people don't know the language, so it's really confusing. This is the way all of those materials, embodied carbon, is all lumped into what's called the industrial sector. 43% of all greenhouse gas emissions are in the industrial sector. That's infrastructure, building structure, substructure, enclosure, finishes, equipment, systems, lighting, everything, all in there. We finally had a breakthrough 2 years ago, and the analysis was done, and core and shell of a building was responsible for about 11% of all that emissions. That's the steel, cement, bricks, glass, sealants, roofing, insulation, all that in the core and shell was about 11%. There's still tens of thousands of materials, so it's still hard to get a handle on this. How the heck are we going to get all these materials to zero carbon by 2040 and 65% reduction by 2030? Well, we took a shot at reshaping the pie, and wow, we found out concrete and steel was half of all industrial emissions. You throw aluminum in and you're over half. It's another 1.5%. But roughly over 20% of all emissions are just two materials, concrete and steel. This is kind of like the big buildings, small buildings, very few big buildings and thousands of small buildings, two materials, and then hundreds of thousands of other materials. So we focus on concrete and steel first. That's how we address this. And we are the gatekeepers. Designing and planning the built environment is responsible for about over 50% of all CO2 emissions. So what do we have to do? How do we get concrete and steel under control? And then all these other products. The first thing is the conversation needs to change so that we understand what the issue is. What I'm talking to you about is one way to do it, but that takes a long time. If we get it in mainstream media, it goes really quickly. And we see that now. All in the media, in the New York Times, in the Guardian, concrete, the most destructive material on earth. We're seeing books written about it now, how bad it is and how we need to get it under control. And steel is not far behind. And Bloomberg, steelmakers next in the crosshairs of climate as climate pressure grows. So all of a sudden now the pressure is on and there's a competitor, and that's huge. All the concrete people want to talk about now is wood. Well, it's not as good as concrete. Well, maybe it is, maybe it isn't. Architects are looking at mass timber for high-rise construction now. The codes are changing. Timber, if it's done right, if it's from sustainably managed forests, is actually a carbon drawdown. And it's northern wood. It's not from tropical forests, so we're not deforesting. And we have plenty of capacity in the global north and in the US, northern United States and Canada to increase our output of mass timber. So it's starting, it's a competitor now for concrete and steel, and that's driving concrete and steel to lower their emissions so that they don't lose market share. It's huge. So now what? We have that. How do we address this whole issue? What is our role? What do we do as architects and planners and landscape architects? Three things: reuse, reduce, and sequester. And starting with reuse, it's a planning, design, specifications, and policy issue. It's everything from repurposing urban areas rather than ripping them all down and having to pour new concrete and everything else. We save a huge amount of embodied carbon if we don't demolish like that and repurpose. Looking at using existing buildings, we're going to see a lot of this now, repurposing and adapting existing buildings post-COVID, using local recycled materials and designing to take new buildings apart when they're no longer needed so that we can reuse those materials. So deconstruct and reuse materials. Lots of firms now are kind of boning up on this and getting up to speed on how to do this. Second thing is reuse. That's the same thing, same issues. We have a lot of control over it. It's everything from growth boundaries to infill, finding sites to infill rather than adding more infrastructure, and going out into and creating more suburbs. But optimizing structures, specifying low carbon materials, and policy. And policy could be huge. We're beginning to see that now. And then sequestering is using carbon sequestering material, like we talked about, sustainable glue laminated wood, bamboo, creating aggregate out of carbon for concrete, actually injecting CO2 into concrete. That's also taking off. Using biomaterials and landscape. How we landscape, we can actually draw down in soil with soils and urban agriculture and a plant material. That's all a drawdown. And at Architecture 2030, we're now setting up the targets. We're calling for an embodied carbon. We're calling for a 40% reduction now below the average. When you specify by 2030, specify 65% reduction, zero emissions by 2040. That's what we're calling for. And we'd like to see actually some high ambition, especially in concrete and steel, actually getting them to zero really quickly. And we have the tools to look at all this now. EC3 will, in your region, you can look at different concrete suppliers and see what their carbon footprint is and see how low they get below the average. There's Pathfinder talking about carbon sites and carbon sequestration. Over time, it'll calculate it all for you. So there's all sorts of things. Solar skyrise, which I'll talk about in a minute. And we just had a breakthrough. Proposed legislation in New York is going through the policy now. There's interest in New Jersey. There's interest actually nationally. There's interest in a bunch of cities in this legislation. What it does is it looks at the procurement process and specifications and says, when we look at bids in the bidding process, if you have a lower embodied concrete, as long as you meet the spec, the concrete spec, everyone's required to provide a life cycle assessment, environmental product declaration. We'll pay for you to do it if you haven't done one already, actually. We'll give you money to do it. And after you submit, the person with the lowest embodied carbon will get a 5% reduction in his cost. And if he then beats you, if you have a higher one, he gets the job. And it costs very, very little. That additional cost is less than 0.5%, because it's giving suppliers roughly a 5% reduction. And when you look at the total cost of a building, concrete's maybe 7%, 10%, and then you get 5% on top of that, you're well below 1%. So it costs really nothing. But that'll drive things down really quickly, because if I'm bidding on a job and I lose the job to someone who has a better, a lower carbon footprint concrete and can meet all the specs, you better believe the next time I'm going to get under him. And that's going to drive carbon way, way down in concrete. We're looking to do the same now in steel. So for example, with steel, if you use local US made steel, you're 50% better just off the bat than something imported from China, for example, where they use coal to make steel. So can we meet the 1.5 degrees C carbon budget? Well, this is Toronto. This was in 1891. Look at the building on the left, the Flatiron, called the Flatiron Building. It's still standing in 2010, but look what's happened to Toronto since then. How did we get all that high-rise buildings and all that glass on four sides of a building? We see the same thing in Las Vegas. If you looked at an old photograph, same thing in London, all these incredible new skyscrapers, glass buildings. We see the same thing in Hong Kong. We see the same thing in every single city. Same growth. How did that happen? Well, 1925, we had the first modern building. It was the Bauhaus building. Structure moved inside. No more masonry walls and then small spans between the masonry walls. We now move structure inside. We're able to actually hang the exterior wall off the structure. This was the first curtain wall building. Now, what was going on in 1925? Well, in 1925, you had the Model T truck came out. Things were pretty primitive. We didn't even have television back then. The first transatlantic call wasn't made till 1927. So that's what was going on at that time, and we had the first modern building. Well, conditions were really bad, and so the architecture community in Europe and the planning community in Europe, and some from the US got together and said, conditions are so bad, we got to get the housing out of the industrial areas. Everybody was using coal like crazy, and it was just real. People had emphysema, nobody lived that long. The average age, was in the 30s somewhere, and people were dying left and right. So they called for function-based zones, getting the housing out of the industrial areas, high-rise buildings, sunlight, solar exposure, free circulation. Le Corbusier set up the column wall separation so that you had columns, you can hang the walls off, big glass areas so you had nice light rather than these small congested areas. And then Philip Johnson, Henry Russell Hitchcock, they had an exhibit at the Museum of Modern Art in 1932 and said, hey, we can do glass buildings and we can climate control them because energy is essentially free. And now we can have the same building anywhere in the world, and that's what you see today. We had the Frank Lloyd Wright building, the Johnson Wax, which had a big open floor plan, and then we had in 49 a glass house, a single glass house in New Canaan, Connecticut, which is a cold climate. And then we had the Lever House, which was also single glass curtain wall building. We had one of the early high-rise, beautiful high-rise buildings by Skidmore. And then by 1956, we had whole cities based on the modern principles. So between 1925 and 1952, that was 27 years from the Model T truck and no TV to 52, we changed the world. We changed the world. Our profession, and the planning professions and the allied professions, engineering, changed the world. And we did that with these tools. T-square triangle, we used to dip the ink pen in an ink bottle, and it would bleed under the T-square and the triangle. We had to scrape it off with a razor blade. Couldn't do a curve because you had a French curve and you couldn't dimension it. We did all that. It used to take a year, 2 years to do a set of working drawings. We changed the world in 27 years with those tools. We didn't even get the first pen till 1960 and the first laptop till 1991. Boy, have things changed. Now, let's look at what's going on in the solar world. I put Las Vegas in here. This is Seattle, Bridgeport, Las Vegas. This is how much energy falls free on every roof, every square foot of roof and every square foot of south facade if it's not shaded in these four areas. That's how much energy falls on a square foot of roof in Las Vegas. That's how much energy falls on the south facade in Las Vegas. This is how much energy a single family and a commercial building uses. This is the average that a building will use nowadays, existing buildings. If you meet the code, the latest code standards, that's how much energy you'll need. That's a square foot, put square foot of floor area. So that's how much energy falls on the roof per square foot and on the south facade. Now let's look at Las Vegas. That's on two surfaces. If we put one on top of the other, on two surfaces, it's off the page already. That's how much energy we get free. We don't have to dig up anything. We don't have to burn anything. We don't need transmission lines, nothing. That's how much lands on the site free. That's how much lands on the east and west facades. That's how much we need in that bright red bar. You mean to tell me we can send spacecraft to the outer regions of the solar system and take measurements of the rings of Saturn, and we can't solve this problem? That's distributed free to every site pretty much in the US. Las Vegas is huge. Seattle even gets a huge amount compared to what's needed. Of course we can do it. And now, why can we do it now? Because battery power is now plunging. It's going down like exponentially, falling through the floor. And solar is now the cheapest electricity in history. Cheaper than coal, cheaper than gas, cheaper than any fossil fuel. It is so cheap. And this year, 2016 was the biggest year we ever had in solar capacity in the US. It was 17 gigawatts. That's how much we built. This year we installed 37 gigawatts. If we install just 40 gigawatts a year from here going out, we transform the grid in 15 years to all renewables. It's that amazing right now. And because of the pandemic, our energy consumption is now expected to be flat through 2025 until we fully recover. And we're getting all sorts of breakthroughs now. Glass, solar glass that lets light through, and it's clear. It's essentially clear glass, and what it does is it absorbs the infrared and ultraviolet and turns it into electricity. That's coming because this has now been perfected, and they now have to make it commercial. So can we meet the 1.5 degrees C carbon budget? Of course we can. It really is up to us to do our part. Thank you.
Wonderful, thank you, Ed. That was great. I particularly like the attention to Las Vegas and Nevada. That was helpful because I haven't seen many of those statistics and information like that. So thank you. I just want to remind everybody to post some questions in the Q&A. Randy, I don't know if you see any. I'll start with one. Ed, the electrification has increasingly become more important recently in the last few years, and how that kind of relates to Las Vegas is Las Vegas has a love affair, right, with our natural gas, either in our mechanical systems, but particularly the restaurant industry. So we've heard that.
You're breaking up again.
Okay, hopefully.
There you go.
Is that working? Okay. Yeah, sorry about that. So how can Las Vegas move more to an electrification?
Yeah, you're frozen again.
Well, so the question is, let me ask, well, till we get them back, you need to require the zero code now. I think next week, probably within a week, we have, so the original zero code allowed you to use natural gas, but you had to offset it with 100%, over 100% renewables. So essentially it de-incentivized the use of natural gas because you were paying double. You were paying for the gas, obviously, and then paying for the renewables to offset it. But there's been such a movement now to electrify. And you see that now in California. I think there are 50 cities now with ordinances to go all electric for all new buildings, that we included an electrification piece that'll be now part of the zero code in about a week. So it's all done. We just have to polish it up and then publish it. What we're seeing in across the board is that for cooking and things like that, preparing food, that induction stoves and ovens is now comparable or even better. Chefs are now coming around to really beginning to love their electrical appliances, and so we're seeing that now, that transformation happen as we speak. And as the grid cleans up, and depending upon how this election goes, we're starting to hear things like a fully total U.S. Clean grid by the year 2035. We think that is so doable given the costs now and what's going on in the U.S. numbers I showed you. So if we do that and we electrify and we pass ordinances that the new buildings coming in now electrify, and then as we renovate, then we renovate out, electrify, give people time to do that. Then then it's a no-brainer. We get to zero carbon. It's either we get to zero carbon, or we're going to live with increasing climate change that for our area in the Southwest is really devastating. I don't think anybody wants to see it get any worse than where it is now even. And so given that, the choice is clear.
Great. I do see some questions here. So one of them from Brandon is saying, does the zero code include formulas to measure the carbon cost of construction of the renewable devices such as solar, wind, and batteries?
The zero code, no, so what we know now is that the solar is for new buildings, zero code deals with new buildings, is cost competitive. So by using it, there may be slight upfront cost, but the payback is very, very quick now, given the cost of electricity and on-site natural gas, or other fossil fuels on site. So requiring that is, because when you're building new, you have financing and all that. It's a no-brainer. When you're building large buildings, those building owners usually have the money to go solar and then recoup it. And if the city and state provide incentives so that it's a no cost in a sense by giving tax breaks, there's all sorts of incentives that you can give, then that makes it even easier to do. But right now, it's cost competitive.
Okay, great. Another question from Stefan is, building with timber has created a range of new challenges, including sourcing it from sustainably harvested timber, transport emissions, etc. So it'd be great to do a lot of CL timber in Las Vegas, but how can we best convince developers to do that?
I think first, as designers, I think everybody loves wood. I mean, just the feel of wood in a building. And mass timber now, it's been shown to be even better in terms of fire protection. It chars and doesn't melt, so it stays up longer, so you can put out a fire. We attended a big symposium. Actually, we actually hosted it with everybody in the timber industry and the NGOs and the certification systems, everybody. And we wanted to get a handle on mass timber and cross-laminated timber. Were we deforesting and all that? Well, there was a lot of discussion. The upshot was that almost all of the mass and cross-laminated timber comes from managed forests in the north, and that they took a real hit for a long period of time. So they still have the forests and the capacity to provide an enormous amount of wood, more than we can specify, coming out of managed forests out of the north. Now, deforestation, when we think about it, happens, in around the equator, in tropical forests. It's not happening in the north. In fact, our tree cover in the global north, or in the U.S. and Canada, is actually increasing. So the question then becomes, what's a sustainably managed forest? And there's a number of certifications out there, and there's a bit of a tug of war going on between which certification is better and which isn't. There is obviously a difference, and that needs to play out. But I can say probably with some degree of certainty, from what I've heard from this entire group, that was manufacturers, certified NGOs, everyone, is that the wood coming out of our northern forests is pretty sustainable.
Yeah, that's great. And I recently read an article there, I believe it was a structural engineer from Vancouver or somewhere in Canada, that they've now pledged to only build buildings out of wood, and even high rise and large structures. So they've sort of taken that step and learned from a carbon perspective, it's really the best way to build. And I'm curious how that would work. As a structural engineer, you don't often get to choose that, or our clients may have a perspective, but yes, they're starting to see this. That's kind of my question. Are you starting to see firms, or even I've heard some mechanical or engineering firms, I believe it was the engineer who did the Bullet Center, PAE, they've now pledged, from what I read, that they're only going to do electric buildings, or provide electrification to all their buildings. So you're starting to see engineers take these bold steps as well. Are you seeing anything?
Absolutely. Our firms now, we just held a global carbon positive online teaching, and we had it all over the world. So in one day was North America, South America. We had another day, and the next week was Europe and Africa, and then we went over to the Pacific and China and Australia and stuff. A lot of talk about what our profession and our planners and our landscape architects are doing, and project after project was shown. And our large firms, the large firms round table in the U.S., and many of the largest firms now in the EU and around the world, are doing incredible buildings that are very, very low energy, sustainable, and very low embodied carbon. Mass design, doing stuff in Africa that's just incredible. So we're seeing that movement happen. And there's also an SE 2050 now. Structural engineers now have what's similar to the 2030 challenge targets that we have in the US, now have a series of incremental targets. They're out to 2050. We got to push them a little closer to 2040, but I don't think that's going to be a hard sell once we get the information out there. I'll probably do an article for Architect Magazine in the November, December on explaining the 2040 date. And we'll push the UN to do that too.
Yeah, that's great. Great. So
you broke up.
You froze up again, Lance.
About that.
No, you're still not back.
You want to?
That's really weird.
Is that better?
There you are.
Yeah, there you go.
Yeah. And my computer's telling me my internet's unstable. So I'll just quickly read. Eric, I was going to read, seeing the information on Chinese Zero Code, what facts internationally with how countries are handling this issue.
Oh, you broke up. I didn't get the whole question. Say it one more time.
So what are the facts internationally with how other countries are handling the issue?
Yeah, so in Europe, we talked to the Europeans, and they are expecting that all countries will have a zero code mandatory in place, zero carbon code standard in place beginning of this next year. So in January, they're all mandated to do that. And they think that that's going to happen. There might be a few outliers, but I think you're going to see that throughout Europe. The Chinese now, we were over in China and presented the zero code when we first developed it to them, and they then developed, asked us a bunch of questions, send over information, which we did, and everything else. And lo and behold, probably 6-8 months ago, they had a zero code come out. They shared it with us, asked for our feedback. And so now they have to get it implemented. We're going to do the same kind of webinar with them in about 2 or 3 weeks for the organization, the government organization that developed the zero carbon code standard in China, and we're going to push their cities to adopt it.
Oh, that's great. So Randy, I'll read, I was going to read another question here, and hopefully I don't break up again. So although ROI and first costs are always big design drivers for commercial developers, however, in Las Vegas, where energy is particularly cheap, it seems like exceeding energy code is a tough argument to have with the development community without deep incentives, and even though it's not always enough. So what do you suggest to reframe this conversation with developers and who may not have the early adoption mentality?
So first of all, in the IECC, I don't know, I should have, but I didn't check what code you're on right now. But with the IECC or ASHRAE, you're using the standard code. So we're not going beyond code in terms of all the requirements for windows and walls and everything else. That's all code standard. So whatever code you're on, we're not going beyond that. The only thing we're doing is saying electrify and then add the renewables, which are cost effective. Now, if energy is really cheap and you can usually get the payback because it's cheaper than gas now. It has really dropped through the floor. But you only have to look at what's happening in the Southwest to understand that your buildings are going to be impacted really quickly if we don't get a handle on this issue. And you have no idea internationally, most people don't, but we got involved in the international scene at the COP, the last COP, and the US is incredibly influential, unbelievable. Nothing happened at the COP until the day before the last day when the US finally said, we adopt the 1.5, and then everybody else jumped in. The US is incredibly influential. So if you want to keep seeing this situation get out of control, and put everybody at risk and have a nightmare on our hands, then keep doing what you're doing. Otherwise, we got to get this under control, and you can do it, and it's cheap, and we're not going outside the code system. We didn't create a whole new code, even though it's called a zero code. It's really just an add-on. It's just an add-on, and that's the beauty of the zero code. It's not going outside the code system.
Yeah, that's great. So Brandon has a question. It says, what do you think is the greatest hurdle to get more cities to adopt the zero code?
I just think it's information, and I think it's essentially the architecture community stepping out there, which they're doing now, by the way, all over the country, stepping out there and promoting it. It's one of the 2021 IECC appendix can be used with the 2018 IECC, can be used with the 2015 IECC. Where I showed you, they've squeezed down.
Yeah.
So it can be used with any of them. So, so it was the AIA that actually got the appendix in the IECC. They're the ones who proposed it, asked for our help, but they're the ones who got it in. And so now they're asking the entire architecture community now to get behind it. They did all the work. Believe me, we just provided expertise, and we're a little cheering section for them. And but they got it in the IECC, the zero code appendix, which can be used with any IECC code.
Yeah, that's great. And we're definitely hearing more from AIA. So that's a wonderful addition here with their new strategic plan in the last few years. So yeah, this is great to have them as a partner with this. And you're right, the education is the key component there, because it's just not known. And I think this year has been evident of that when we've been hearing it more from the carbon positive conferences and from Vincent and yourself.
And from what I showed you for on-site, you need so little because of the amount of energy that falls on your site, on every site in Las Vegas. It's no, you need half of what they need in Seattle, less than half probably, because you get so much sunlight. In fact, I know we're all getting tired of the sunlight. We want a little cloud cover.
Yeah.
Now.
Yeah.
But to generate energy, it's like.
Yeah, absolutely. And we are moving in that direction. Our renewable portfolio with our SB 358, 50% renewables by 2030. And so we've been pushing that and to get more aggressive. So we're trying to take advantage of it, I think, in Nevada.
I think it's a no-brainer.
As you should. Yeah, absolutely.
Yeah, what I'm hearing and what I've heard from you this evening is, with so many very really positive things that are going on with the industry and with controlling the carbon emissions, and the plan actually that you have laid out kind of step by step, this is what needs to happen. I cannot for the life of me understand why. I mean, it's doable. It is so doable that I can't understand why we wouldn't just everyone move forward with that and get it done. I mean, it's all there, really, Yeah,
why would we take a chance?
Exactly.
On destroying our environment where we can't even live it? I mean, we have some issues in the Southwest that they don't have in other places.
That's
right?
true.
We're on the front lines of this. Do we want to see this get worse? I don't think so. I live, in Santa Fe. It is, it is drop dead gorgeous here. I love living here. I would not want to move, but we haven't seen rain now in months.
Yeah, same here. It's been 6 months since we had rain.
Tinderbox.
Yeah.
I mean, you live in in a forested area. I've been clearing around the house 20 feet now because we're deathly afraid of what could happen. We had one big fire here right in Santa Fe, right up at the ski basin, and the smoke was unbearable for weeks at a time.
Yeah.
Yeah.
So
you're right. You couple that with no rain in 6 months and the hottest September on record too. So those two that do not work well together, and we're seeing more of that. And every year we one up ourselves, it seems.
Yeah.
It's unfortunate.
And we can reverse it. The issue is it's so reversible. It's cost effective now. We know how to do it. We give people time to do it. We don't have to have everybody doing it tomorrow. When you're going to renovate, that's when you do it. It's just so, it's just a no-brainer. I'm hoping that the feds will take a leadership role soon, and a lot of the states now are really looking to take a leadership role. In fact, there was a bill now just introduced in Congress to electrify all transportation by 2035 to follow California. Yeah. That's a no-brainer. For example, I'll give you one example. I had a company, there was consultants for a company come and say, we're huge. We build these huge warehouses all over. How can we buy offsets? I said, offsets? I said, you don't want to buy offsets. You have a one-story building. You throw a few skylights in there, and a warehouse is the lowest energy use of any building. It's like 9,000 BTUs a square foot a year, or 10. Schools are 30 or whatever. So it's the low. I said, you don't need much energy. Just put solar on the roof, and not only can you provide all the energy, but you can offset any construction or anything else. And existing buildings, if you do it on your existing buildings, you could supply, you know, the neighborhood. And what about all the turnaround space and everything else? And if, you know, you just pop some collectors, you know, nobody wants to sit out in the sunlight, especially, you know, if it's really hot in the pavement, it's all pavement and everything. You do some shading and you stub in for electric trucks. When they electrify the trucking, long haul truck comes, they're unloading, they get recharged with your system. You charge them for it. It's a moneymaker. I went, wow, I never thought of that. Offset, maybe we don't want offsets. Maybe we want to make the money ourselves. I mean, these things, we have to start thinking like that.
Yeah.
Really make change.
Absolutely. Well, I think that's a great way to end this evening, Ed. We thank you for your time this evening, for your insight and wonderful knowledge. And it was a great presentation and a wonderful way to sort of end our year before we start the holiday season. It's incredible to say that. But yes, thank you for your time. And thank you for everybody this evening. And thank you to our sponsors. And I wish everybody a good evening and stay safe and healthy and wear your masks.
Thanks, yeah, and just hello to all my friends. I see a few of them online in Las Vegas. So just
right.
a hello to Alfredo and everybody else.
Thank you.
Right.
Wonderful.
Thank you, Ed.
Thank you, Ed.
Thanks for having me, by the way.
Wonderful. Yes, thank you. Have a wonderful evening, everyone. Good night.
Good night.